Hello everyone, welcome to our YouTube channel Calculus Hub UPI Cairo. This video is video number 2 in Calculus 2 course, which is titled as Reduction Formula. I'm Hisham Hosni Hussein, Associate Professor of Applied Mathematics. Please prepare your pen, your notes, and let's go. I'd like to start by providing a definition for the reduction formula. It's simply a strategy or it's a technique that's used in calculus to solve some types of integrals, specifically those involving high powers of trig, exponential, or even algebraic functions, by expressing them in terms of simpler versions of the same integral. Think of it like a recursive loop. Instead of solving a massive problems all at once, you can reduce the exponent, usually denoted by n, till the integral becomes a basic form that you already know how to solve. Let's start by finding the reduction formula for the integral of cosine to the power n x dx. Here we are going to use the integration by parts techniques. How come? If we split this cosine to the power n to be product of two functions, cosine to the power n minus 1 x times cosine x dx. In this case, we need to choose which function to differentiate and which one to integrate. So if we choose cosine to the power n minus 1 is the function to differentiate, cosine to the power n minus 1x is the function to differentiate, and the function to integrate is cosine x. So u dash in this case will be cosine to the power n minus 1 will be n minus 1 cosine to the power n minus 2 x times the derivative of cosine itself, which is negative sine x. Regarding v, v dash is cosine x, so its integral is sine x. So the integral in this case would be in would be u times v minus the integral of u dash times v. So in here will be in after substituting in the rule, it's u times v, this cosine to the power n minus 1x times sine x. This u times v, negative and another negative, it's positive, n minus 1, it's a constant, integration, cosine to the power n minus 2 times sine, which is sine squared. So this cosine to the power n minus 2x times sine power 2x dx. As mentioned in the lecture, we can replace this sine squared by 1 minus cosine squared x. So the integral in this case will be in equals to cosine to the power n minus 1x times sine x plus n minus 1 multiplied by the following integral, integration of cosine to the power n minus 2 distributed on the expression 1 minus cosine squared. Cosine to the power n minus 2 times 1, it's simply cosine to the power n minus 2. So it's integral of cosine to the power n minus 2x dx minus integration of cosine to the power n minus 2 times cosine squared by adding the powers, it's cosine to the power n. So it's the integral of cosine to the power n as a function of x dx. So now looking at the main form of the integral, which is cosine to the power n, we replaced it by in. So we can do the same here by replacing this cosine to the power n by in, and consequently this cosine to the power n minus 2, we can replace it by in minus 2. As we know that the target is evaluating in, so solving for in. How come? It's in equals to the first term, keep it as it is, it's cosine to the power n minus 1x times sine x plus, here we have n minus 1 can be distributed on in minus 2 and n minus 1 times in minus 2 minus n minus 1 multiplied by in. Switch this in to the left hand side, so we get in plus n minus 1 in. This equals to the term cosine to the power n minus 1 times sine, keep it as it is again, plus n minus 1 in minus 2. So at the end, we need to solve for in. So factor this in. We will get here we have 1 plus n minus 1 equals 2. After simplifying this bracket, we can say that this can be reduced to be in equals to the same form. So at the end, in will be just divide by n for both expressions or for both terms. It will be 1 divided n cosine to the power n minus 1x times sine x plus n minus 1 divided n in minus 2. So if you would like to evaluate the integral for example, for integral of cosine to the power 5x dx, simply substitute in this in. So I5 will be here. You will just replace n by 5 at n equals to 5. So I5 is 1 over 5 cosine to the power 4 times sine x plus 4 over 5 I3. Still, we need to evaluate I3 at n equals to 3. So I3 is 1 over 3 cosine to the power 2 x times sine x plus 3 minus 1 is 2 divided 3 I1. Simply I1 is the integral of cosine x. So integral of cosine x is sine x. Now we have I3. Substitute in this I3 to find I5. That's it. Okay, so following the same technique for finding the reduction formula for in equals to integration of sine to the power n x dx. Here we can do the same by splitting the sine to the power n into product of two functions. The first one is sine to the power n minus 1 x times sine x dx. As we know, we will follow the integration by parts technique. U is sine to the power n minus 1x. U dash here is n minus 1 times sine to the power n minus 2x times the derivative of sine, which is simply cosine x. V dash is sine x. So V in this case would be negative cosine x. The integral now would be u times v minus the integration of u dash times v. So the integral would be in is u times v, this negative sine to the power n minus 1x times cosine x, u times v, negative, negative, it's positive, n minus 1 constant, factor it out, integration of sine to the power n minus 2x, cosine times cosine, this cosine to the power 2x dx. Cosine square, we can replace it by 1 minus sine square x. And now distribute the sine to the power n minus 2 on both terms in the expression 1 minus sine square to get at the end in is the first term, keep it as it is, negative sine to the power n minus 1x times cosine x plus n minus 1, which is common, times sine to the power n minus 2 times 1. It's sine to the power n minus 2. It's integral. We can recall it n minus 2 minus sine to the power n minus 2 times sine squared, sine to the power n. We can replace it by in. So the next step, as we did before, switch this in with n minus 1 to the other side with a positive sign. So in plus n minus 1 in equals to the first term, keep it as it is, negative sine to the power n minus 1x times cosine x plus n minus 1 multiplied by in minus 2. So we can factor this in the left hand side. In, the remaining factor here will be 1. The remaining factor here would be n minus 1. So after simplifying this expression, we will get it in. So in at the end. Now we have in equals to this right hand side. So only in equals to negative 1 over n sine to the power n minus 1 x cosine x plus n minus 1 divided in in minus 2. Now going to another type of reduction formula, which is the integral for sec to the power n x dx. Before, we splitted only one function, like the integral for sine to the power n. We split sine x from sine to the power n. The same for cosine. We split cosine x from cosine to the power n. But here we cannot do the same. In the integral of sec to the power n, we'll split 2 of sec to the power n minus 2x times sec squared x dx. So here we have product of two functions following the same technique, integration by parts. This is u, and here this is v dash. So u, which is sec to the power n minus 2x, its derivative will be n minus 2 times sec to the power n minus 3x times the derivative of sec itself, which is sec 10. Sec x, 10x. What about v dash? V dash here is sec to the power 2x. So v in this case, the integral of sec power 2 is simply 10x. So apply the integration by parts, u times v minus the integral of u dash times v. So I is u times v, which is sec to the power n minus 2x times 10x minus the integral of u dash times v. Negative, and we have n minus 2, which is constant. Factor it out. Integration. Sec to the power n minus 3 times sec, this sec to the power n minus 2. 10 times 10, this is simply 10 squared x dx. Okay, now what about 10 squared? We can replace it by, to be expressed in terms of sec, we can replace it by sec power 2x minus 1. Sec squared x minus 1. To distribute the sec to the power n minus 2 on sec squared and 1. To get in this case equals to, rewrite the first expression as it is, sec to the power n minus 2x times 10x minus n minus 2 constant, sec to the power n minus 2 times sec power 2, this sec power n, which is in, minus sec to the power n minus 2 times 1, this in minus 2. Now, solving for in, switch this in to the left-hand side, we get in plus n minus 2 in equals to, keep the first term as it is, sec to the power n minus 2x 10x. Negative, it's positive, n minus 2 in minus 2. And now factor in, take in as a common factor, we'll get in 1 plus n minus 2. This equals to the right hand side as it is, sec to the power n minus 2x 10x plus n minus 2 in minus 2. Okay, so at the end, we, after simplifying this 1 plus n minus 2, which is n minus 1, so solving for in, dividing by n minus 1, it will be 1 divided n minus 1, sec to the power n minus 2x times 10x plus n minus 2 divided n minus 1 in minus 2. Another reduction formula, like in equals to integration of ln x to the power n dx. Here, we need not to do any splitting. Why? We'll apply the integration by parts technique. U will be ln x to the power n, v dash will be 1. So u dash here will be n ln x to the power n minus 1 times the derivative of what's inside. Derivative of ln x, it's 1 over x. V will be x. Apply the integration by parts, u times v minus the integration of u dash times v. In will be u times v, which is x, times ln x to the power n, this u times v, minus the integral of u dash times v. X times 1 over x, it will be 1. minus n constant integration of ln x to the power n minus 1 dx. Integration of ln x to the power n, it was in. So the integral of ln x to the power n minus 1, it will be in minus 1. So in will be x times ln x to the power n minus n in minus 1. Think about another integral like in equals to integration of x to the power n times e to the power x dx. Think about this integral from the perspective of integration by parts. U, as we mentioned before, u is x to the power n, so u dash will be n x to the power n minus 1. V dash is e to the power x, so v is e to the power x. U times v minus the integral of u dash times v. So in will be u times v, this x to the power n times e to the power x, this u times v, minus the integration of u dash times v minus n integration of x to the power n minus 1 times e to the power x dx. This integral x to the power n minus 1 e to the power x dx, this integral is called in minus 1. So in as a reduction formula will be x to the power n times e to the power x minus n in minus 1. So for example, if you would like to find I3, so I3 will be expressed in terms of I2. To find I2, it will be represented in terms of I1. I1, it will be represented in terms of I0. So just find I0. What is I0? This is simply the integral of e to the power x. With the same idea, find the reduction formula for integration of x to the power n times sine x dx. As we did before, here this is u, this is v dash. U is x to the power n, u dash is n x to the power n minus 1. V dash is sine x, so v is the integral of sine is negative cosine x. U times v minus the integral of u dash times v. So in would be u times v, this negative x to the power n cosine x. U times v, negative, negative, it's positive. N constant, factor it out, x to the power n minus 1 times the cosine x dx. Still here we have x to the power n minus 1, okay, but multiplied by cosine x, which is not the same as the main integral, which is x to the power n sine x. So do another step for the integration by parts. The same, u is x to the power n minus 1. So u dash will be n minus 1 x to the power n minus 2. V dash is cosine x, so v is sine x. Now apply the integration by parts technique. U times v minus the integration of u dash times v. Okay, so in this case would be in will be the first term, don't forget it, the first term, keep it as it is, negative x to the power n cosine x plus n u times v, which is x to the power n minus 1 sine x, u times v minus n minus 1 times the integral of x to the power n minus 2 times sine x dx. Okay, this x to the power n minus 2 sine x, this integral is similar to the original one. Here, x to the power n, so it's called in. But here, x to the power n minus 2, so it's in minus 2. Then in at the end will be the first term, don't forget it, negative x to the power n cosine x plus n distributed on these two terms, it's n x to the power n minus 1 times sine x minus n times n minus 1 in minus 2. So here the reduction is 2 by 2. I4 leads to I2, I2 leads to I0, I6 leads to I4, I4 leads to I2, I2 leads to I0, and so on, sine x. Don't forget this expression. Don't forget this reduction formula. That's why, as we need to think about this reduction formula. What if we have in that equals to the integration of cosine inverse cosine inverse x to the power n dx. Here, we will do some substitution step by letting z equals to cosine inverse x, which means that in cosine z equals to x, and after differentiating both sides, so negative sine z dz equals to dx. So it's clear for me now that in in would be replace this cosine inverse by z to the power n. Replace this dx by negative sine z dz, negative sine z dz, and continue with the same steps like this one. So we can conclude that in the integral of cosine inverse x to the power n leads to the integral of z to the power n times sine z. Consequently, in equals to integration of sine inverse x to the power n dx. This leads to the integral of z to the power n times cosine z dz. Do first the substitution and then go with the integration steps for the integral of z to the power n times cosine z.